let's look at the functions for the autonomic nervous system. And I've made reference to it, but let's look at the words and kind of what they say here. Sympathetic, again, like I said, fight or flight, right? This is getting ready. This is getting the body ready for very physical, intense activity. Generally, we think of it as fighting the bully or running from the bobcat in the parking lot. But we have norepinephrine and epinephrine kind of involved with this process. Norepinephrine is usually being secreted from the postganglionic neuron. So that's what's causing the effect for sympathetic. Epinephrine is secreted from the adrenal medulla there. And that helps to further bolster the norepinephrine effect, the sympathetic effect on the effector. Increases heart rate, blood glucose levels, diverts blood away from the digestive tract and towards skeletal muscles. So getting the body ready, prepared for fighting. Tonically regulates heart, blood vessels, and other organs. Again, it does this in tandem with the parasympathetic, but this is the primary individual involved with maintaining good heart contraction, good blood vessel pliability and tone. Parasympathetic is rest and digest, okay? Rest and repose, I think some books have put in, but rest and digest. It slows things down, or, well, it doesn't slow everything down. It slows the heart down. It slows respiratory down. Again, think of it. When you're sitting there seated, eating a sandwich, you're calm. So it's slowing the heart. It is slowing down the breathing. So it's causing those things to be not as active. But for some things, it's stimulatory, like the digestive tract. It's in its name, digest. So when it comes to this, rest and digest, it actually increases digestive activities. Because we have such a multitude of responses, sympathetic can be excitatory, parasympathetic can be excitatory or inhibitory. As you might have guessed it, we have acetylcholine, we have norepinephrine, so we have different types of transmitters, different types of receptors. We have cholinergic, acetylcholine, choline, adrenergic, norepinephrine. Another name for norepinephrine is noradrenaline. So noradrenaline, adrenergic. So norepinephrine is adrenergic, acetylcholine is cholinergic. All preganglionic neurons in both sympathetic and parasympathetic, so again, all, acetylcholine is used. The neurotransmitter secreted from the vast majority of postganglionic parasympathetic is acetylcholine. Okay, and remember, these synapses again are called cholinergic. So all preganglionic neurons secrete acetylcholine. Parasympathetic, cholinergic. Remember, acetylcholine was stimulatory. Norepinephrine. Norepinephrine is secreted by most sympathetic postganglionic neurons. Okay, norepinephrine, epinephrine, they're both secreted by them. Okay, and again, these are called adrenergic. Excuse me. So, summary, because you'll be asked, what neurons secrete acetylcholine in the autonomic nervous system? All preganglionic neurons do, in the sympathetic and the parasympathetic. Who is secreted from postganglionic neurons? Well, in the parasympathetic, it's cholinergic, it's acetylcholine. In the sympathetic, it's norepinephrine or epinephrine. And here, this is just a picture to kind of reinforce that concept. We have transmission that we generally think of as a nerve extending out, going to an effector and causing contraction. In this system, at least that we're talking about, the autonomic nervous system, we are going to smooth muscle. Smooth muscle can have a couple different ways that it presents. It could be in layers, in sheets. where we turn it all on at one time, or we can have it to where I go and give off branches to each individual muscle fiber. So it's smooth muscle is a little weird in that regard. When we look at all of the most common type of smooth muscle, it looks like this picture right here. As a autonomic neuron comes in, excuse me, frog in my throat. As this axon comes down in here, you can see it doesn't have, it just kind of goes in there and it goes as when, this one, okay. As you can kind of see, there's not a traditional synaptic knob here. It has these bulges along the length of those axons. These are referred to as varicosities. Varicosities are what hold those neurotransmitters, have those synaptic vesicles, and release neurotransmitters. So as this motor axon, as the electricity, as the action potential travels down this axon here, it'll trigger those varicosities to release their stores of neurotransmitters and stimulate the smooth muscle, as you can kind of see down here. Okay. And actually, you can kind of get both a sympathetic and a parasympathetic event here, an antagonistic event. Okay. These axons extend or form synapses as they pass by it. So they're referred to as synapses en passant, which I just love saying like that. So it just means synapses that form in passing. That's all it means. So there's not a true synaptic knob going and forming a neuromuscular junction like you think of when you think of the nervous system and muscles. Very different in that regard.